Hi, my name is Barry, and in this video I'll show you how to create your first project in Libgdx. We'll use the setup jar to create your project, learn how to import assets, learn how to draw things to the screen, and then how to take input so we can move things around. Alright, so to get started we're going to need to install a couple things first. If you don't already have Intellij, I recommend using it for Libgdx, and you can download it from Intellij's website. Just Google Intellij download. You can use the community version, it's perfectly free. You can use it for commercial projects. That means you can sell your game if you get to that point. And it has all the features that we'll need. If you want to pay for the upgrade, that's up to you. But the Community Edition will work just fine. You can use this URL here. And once you have it installed, it'll open up like this. The next thing that you'll need is the Libgdx Setup Jar, so we can actually create a Libgdx project. To get that, you'll want to go to Bad Logic Games website, so libgdx.badlogicgames.com, and go to /download, or click the download link at the top. Click this big red download setup app, and it will download a file called gdx-setup.jar. And you can see I've already downloaded it here, and I've moved it to a folder that I prefer. You can move it wherever you want, just make sure you remember where you put it. And we'll use that to create our first project and get going. Now that we have Intellij downloaded and the Gdx Setup Jar downloaded, we can start creating our first project. The setup jar is going to help us do that and generate the scaffold project. We can either double click it here, or you can go to a terminal and you can type java-jar and the path to your setup jar. When you run that, it will open up the setup app. And the app looks like this. Here's where we'll put in a few pieces of information about our project, tell it where on our file system to put it, and what kind of features that we want to include by default. So let's go ahead and name this GDX Juggler. We're going to create a simple ball juggle game. For package, this is usually a reverse domain name style format. So if you have a studio, you could say com.yourstudioname.jugglergame, something like that. But for this, you can just follow along with me, com.lmg.juggler. The game class is the name of the actual class that we will create for our root game object. So let's call this GDX Juggler Game. And that'll create a class called GDX Juggler Game, and we'll have a file called GDX Juggler Game in our project once we create it. Next, we're going to tell it where we want this to live. Now, I'm going to create a folder on my desktop, and you can create a folder wherever you'd like, but I'm going to create one on my desktop just so it's easy to find. I'm going to call it GDX Juggler Game. We'll click open there, and that's where it's going to put our file. Now, Android SDK, you can ignore that for this tutorial. We're not going to do it. We're not going to target Android. For sub projects, we're only going to worry about desktop for this one. So just uncheck everything except for desktop, and this will make sure that our project will run on Windows, Mac, Linux, anything that can run Java app and has graphics, OpenGL over it. We're not going to use any extensions for this. We're going to do just bare bones Libgdx code to make this work, so we're not going to pull in any extensions. So let's go ahead and uncheck box 2D. Third-party extensions, you can ignore that for now as well. We won't be using any extensions. Now, we are going to use Kotlin, so we have to tell the setup jar that we're going to do that. So let's click Advanced, and that's going to pop up a separate window, and we can just check Use Kotlin. We click Save, and that'll save that property, and then we click Generate. Now this is going to generate our project. It's going to download some stuff for us. You'll see some Gradle commands running, and once it's finished, you'll see this Build Successful, and it'll tell you exactly how to import the project from any IDE, which is what we'll do next. Alright, now that we've created our project, we can get going. So the next thing we're going to do is we're going to close out our GDX app. Now let's go find on our folder system where we created that project. So let's go to Desktop, GDX Juggler Game, and you'll see this folder structure. Make sure you've got a build.gradle file, that's super important, and then you should see Core, Desktop, and Gradle as the three folders. You can ignore the other files, they're important, but we don't need to worry about what they do right now. So make sure you've got those. If you don't, go back to the beginning of this tutorial, make sure you've followed all the steps, and once you have this folder structure, generated from the setup app, we're ready to go. So the next thing we're going to do is we're going to import the project into Intellij. So let's open up Intellij. And once you open up Intellij, if it's the first time, you'll have something like this. If you already have Intellij and you have another project open, it's just File, Open, or File, Import Project. So let's click Open or Import. And then let's find that build.gradle file we were just looking at. So we'll click on our folder, click build.gradle, and click Open. Now when it prompts you, it'll say open as file, or open as project. We want to open as project, so it'll import the whole Gradle project. Once you run that, it'll run something like this. You'll see a build successful at the bottom while it's doing all of its Gradle work. And you have successfully imported your game. Now, by default, Libgdx creates a bare bones game, and you can just run that game and it'll start. So let's do that next. If you go down to the bottom of Intellij, you'll see a terminal. Click on that, and once the prompt is there, type in //gradle w desktop:/run. And you should have the first GDX Juggler game running. And it should look something like this. Now, kind of ignore what it looks like. This is always the first project, but that's running. If you've got this is a working Libgdx project. So you can go ahead and close that. Now, it's not everybody's cup of tea to go to the command line and run Gradle commands and try to remember how to start projects, especially if you're just working in code and you want to click a button to see what's happening. So let's go ahead and set up a run configuration for this. So to add a run configuration, we'll go up to the right corner here and click Add Configuration. And when that opens up, click the plus button and select Gradle. Now it's going to start off unnamed, so let's name this Run Desktop. And then in Gradle project, click the folder, and it knows about the two modules, so we're going to select the desktop module. Then in tasks, if you start typing run, you can pick run, and that's the task that we want to run. You can leave the rest blank because we don't need any extra options. Let's click apply, click OK, and now you'll see in your run configurations at the top a Run Desktop. Now we can click this green play button, and it does exactly what we did from the command line. And we don't have to type anything in, don't have to remember anything. So now we have this green button, and also we have the debugger available. If we run with the green bug icon, that'll run it in debug mode. It may take a few seconds the first time to get it started up. The debugger has to attach, it has a lot more symbols. And once the game starts, it'll look just the same, but now we could be debugging if we wanted. We could set breakpoints and things in our IDE. So this is very important for a ergonomic development experience going forward. Now we've got our run configuration ready to go, and we're ready to really start diving into the project and figuring out what is going on in this game. Okay, so our project is good to go, and we can dive in and start making some changes. To make some changes, we need to know what's going on. So let's look at the project structure. On the left-hand side, you'll see your project window, and we can expand out the game. And you'll see the general module structure. Look, it's our folder structure from before when we looked at the file system, but you'll notice we've got the core module and the desktop module, and those are highlighted because those are the code modules that we're worried about. Every Libgdx project creates a module per platform, and then the core module where all of our shared game logic goes. So we'll be mostly working in core, and then the desktop, we might touch that towards the end to adjust some sizes. But let's go ahead and explore the core module. So let's open it up, and we've got the source folder, which is where all of our code will live. So let's go ahead and expand that out, and you'll see com lmg juggler. Remember that package that we created in the setup jar that named this package. And you'll see gdx juggler game. So let's go ahead and open that up. A quick tip for Intellij, if you would like, you can also hit Command-Shift-O and type in GDX, whatever class you're looking for, and open it up that way. Now, something you might notice here is that this is a .java file, and I said we're going to write Kotlin, and we told Libgdx we wanted to use Kotlin. Well, the setup jar, when we check that use Kotlin button, it does set up the project to use Kotlin, but it doesn't change the behavior of the default project. It just copies the same files that it would otherwise. So before we look at how this works, let's first just switch this over to Kotlin so we're not switching back and forth. So you can either use the menu system to find the convert to Kotlin action, or you can use Command, Option, Shift, K. It's a lot to do, but that will convert the current file from Java to Kotlin automatically. So let's do that, and now we've got our Kotlin file. Once we've done that, let's go ahead and do that in our desktop project as well. Since there's only one other Java file, let's go ahead and open Desktop Launcher. We're not going to spec this too much right now. Just go ahead and do the same thing, convert to Kotlin. And now our whole project is Kotlin because there's only 2 source files in the beginning. So let's go ahead and close out Desktop Launcher and just look at GDX jailbreaking. So the first thing to point out here is that it extends an application adapter. Application adapter is a Libgdx class which implements application listener and basically gives us our hooks for the life cycle of the game. It gives us access to the game loop, when the game's created, when it's paused, resized, disposed, and the application adapter implements all those with the default implementation, so we only have to worry about the ones we want. So we only start overriding stuff once we need it. And that doesn't make a lot of sense to you right now, and you're just like, hey, show me what code I need to write. Don't worry about it, I just wanted to explain it so that you've heard it, and when it comes up again later, maybe you'll remember that you'd heard it before. We ran the game, and it's not super interesting, but there's 2 major pieces that it does for us that I'd like to take a look at in this tutorial, and we'll start with making our modifications there. It sets a background color, so you notice the background was red, and it draws a custom image to the screen. So how does it do that? So right up front, we've got a sprite batch here, and an image texture, or a texture. Then in create, we see that we create a new sprite batch and a new texture, and we tell it badlogic.jpg. Now where does that live? And where does that come from? Badlogic.jpg lives over in our left-hand side in our assets folder, comes with the setup project. And if you double click it, you open it up, and there's that image that we see. So that assets folder is where all of our images, music, fonts, any assets we need to pull into a game, they'll live under that assets folder somewhere. And by default, a texture takes an internal path which starts at the root of the assets folder. So badlogic.jpg maps directly to that image. So this texture holds the pixels for that image. Now we'll switch that out pretty soon, but first let's change the background color and see how this image is even drawn to the screen. So if we move on down to the render method, you'll see the first 2 lines are GL calls. And now these are GDX wrappers around OpenGL. And they're basically saying, hey, set the clear color for when we clear the frame. And this is where you see there's a 1 for red, and 0 for green and blue, and 1 for alpha. So it says, hey, full red, no transparency, just make it as bright red as possible. And then gdx clear, we're clearing the frame, say, hey, clear everything we had before, don't keep anything. So if you don't understand what these are, the key thing to know is these tell the game, clear everything from the last frame, we're going to draw new stuff, and any pixels we don't cover, fill them in with red. So that's the key piece here. The next thing to notice is we start drawing from our sprite batch. So our sprite batch, you have to begin it and end it. And in between, we can draw things to it. And when we end it, it will flush those straight to the frame buffer. So this isn't drawing every time you draw necessarily. It can do some optimization underneath. There's a lot more going on under there. If you're really interested, dig in. It's outside the scope of this video. And there's lots of things to know about how this works. Lots to understand there. So the draw call takes an image, which is our texture. So the texture holds the pixels for our image. And then this tells us where we should position it, 0f, 0f. Now, we'll get to what that means for Libgdx in a minute, and as far as where on the screen that is. But as you can tell, bottom left is 0f, 0f. The next thing we want to do is we want to replace that red, the bright red background with our own color. So let's define a new color. Let's do a private var background color, and let's use some specific values. Now notice I'm using values over 255 here rather than just 1f, 0f. The colors in Libgdx are defined as 0 to 1 values, which are a percentage essentially of the 0 to 255 available values for any given channel on a color. So I'm defining them here so that I can keep them straight. If you like to work in 0 to 1 range and that makes sense to you, go for it. I come from the web world, and out of 255 lets me know kind of where it falls in the 00 to FF range for me, for the hex side. So once we've got that defined, let's go use it, and we'll say bgcolor.r, and then we'll say bgcolor.g, and we'll say bgcolor.blue, and bgcolor.a. So we define our color and we apply it to our clear color, and now we will use that whenever we run our game. So now instead of the red, we should have our color. And if you've already run this, if you're ahead of me, then you'll notice we've got this calm purple in the background, much less harsh than that red. So the next thing we'll do is we will swap out this bad logic image. To swap out the image, what we need to do is we need to find our image, drop it in the assets folder over here, and then replace this string that's looking for the bad logic image and look for our image. So I went ahead and downloaded this soccer ball image because we're going to be making a bouncing ball game here. And it's Creative Commons 0. Go ahead and download it if you want. Or if you want to use your own image or draw something new, feel free to do that and then come back to the tutorial once you've got that image. So I've downloaded that image and I'm going to drag it over to my assets folder. And it'll pop up and say, do you want to refactor this? Yes. And so now we can see our soccer ball is in here. Now I prefer to name things without capital camel case for assets. So I'm going to rename this to soccer-ball.png. Now, to get this in our game instead of the bad logic logo, we'll just change soccer-ball.png here for the string. Now let's run it, and we should have our image in the game. Nice purple background, custom ball image, ready to go. So let's close this out, and we can just delete the bad logic image altogether. It'll safe search it for us, and it's gone, and we are ready to move on to something else. The next thing we're going to do is we're going to write some code to move this ball. Before we do that, though, we converted this from Java to Kotlin, and it did some things that that Java does that we can actually avoid here. So we don't want these bright batch or texture to actually be nullable at this point. So let's change these to private latenit vars. Take off the nullability and do not set an initial value. Private latenit var, and take those off. Late init, if you type it correctly. So this means they can never be null. This is just going to make things easier, and you'll notice down below now we've got these weird bangs. If you're not familiar with Kotlin, those are saying the double bang says, hey, I know this is not null, so don't worry about nullable. Now we absolutely know it's not, so there's no use to have these bangs, so we can go ahead and clear that out. And we can go ahead and clear that out here. Now, along with the image and the batch, if we're going to move the ball, we should keep track of a position. So let's say position vector 2. And we won't actually make this one late init because we might change it over time. Let's just go ahead and make it a normal variable. Now, if we do this, we'll need to come down here to where we're drawing the image and say, hey, position.x, position.y instead of 0, 0, 0. Now this is still just going to draw in the bottom left corner because we haven't changed the 0, 0 position. So let's initialize our position with in the middle of the screen at the bottom. We'll just leave the y as is, and let's position this in the middle of the screen. So let's say position.set, and for x we're going to set gdx.graphics.width divided by 2, so half the screen, minus image.width divided by 2. And then we'll just say 0 for y. Now, we have to divide the screen in half because we only have the width of the screen. We don't have the center point. So that's why we divide the width of the screen in half. And then we subtract the width of the image because, as we've seen before, the x position that we're drawing to is actually the bottom left corner of the image. So if we draw the bottom left corner of the image exactly the middle point, we're going to be off center. So this should draw our ball in the middle of the screen at the bottom. So we'll run the game, and there we go, perfectly centered. Okay, now let's move the y position. We got it centered in the middle, now let's move it to the top of the screen. So we can change the y position to gdx-graphics.height minus image.height.toFloat. Now we have to use that toFloat because the vector takes a float value, and both heights on these are ints, so we have to make one of them a float to do the conversion for us. Now, if we do that, our image should be positioned at the top, minus the height of the image, so it should be all in view when we start, and right in the middle. So let's run the game, make sure we got it in the right spot. And we do. So now, a ball just hanging in the air doesn't make a lot of sense, so let's make it fall. Alright, to make the ball fall, we need to apply some kind of gravity. Now, we're going to calculate this ourselves, so we're not using a physics engine. So let's just create a variable to hold our gravity. So private var gravity vector2 equals vector2 0 if we don't want any horizontal gravity, but we do want negative 9.8 f meters per second y gravity. So that's down at 9.8 meters per second. And this is redundant here on both of these, so let's go ahead and clean that up while we're at it. Alright, so now we need to apply this gravity every frame. So normally in a game you've got your update, draw, update, draw, update, draw. That's kind of the loop. So let's go ahead and actually make those methods, and so that our main render method calls update with a delta time and then a draw to make sure we draw everything to the screen. So let's say update, and then we'll say delta equals gdx.graphics.delta time, and then we'll say draw. And let's go ahead and cut all of this out, and we will create these methods. So private fun update delta float, and private fun draw to draw. And for draw, we'll go ahead and paste that code that we just had before. So this is always doing our same draw stuff. This is how we actually render stuff to the screen. And an update, this is where we'll actually do our update. So we need to calculate how far down this will go each frame. So we want to adjust our position by the gravity. So let's say val adjustment equals gravity dot copy dot scale by delta. So 9.8 meters a second, the delta is a fraction of a second, so we need to scale it down by the delta. And then we will say position.add adjustment. And now update will run for the delta time, and then we'll draw our ball. And so let's see what happens here. And that's some pretty slow gravity. So the next thing we're going to do is we're going to actually get this to scale properly, because now it's just going 9.8 pixels a second, which gets scaled down, which is very, very slow. Our gravity is wrong, but it does show us that we can move the ball. And so we have our update our position, draw our stuff, update, draw. That's the game loop. So from here, we could stop and you could start playing with this and start applying whatever formulas and logic you want to start moving things around, add new images. You have all the tools that you need to do that. But this isn't too fun yet, so we're going to try to add a little bit of fun to this. So I'm going to kind of speed things up for the next section of this tutorial. I'm not going to spend nearly as much time line by line. I'm going to mostly be copying some stuff over from a pre-built project that we're working on here, just to kind of show you what you could do with just one image, one class in Libgdx. So the first thing to get this working right is we need pixels per meter, gravity, and velocity. So I'm going to go ahead and initialize those like so. I'm going to copy over our current gravity with the things that we need now. So we have pixels per meter, which is 1. We'll adjust that in a second. Gravity, which we had before, and a new velocity vector, which we'll keep track of because gravity is an acceleration. It's not a constant. So we need to keep adding that gravity over time to our velocity. That will make it feel more, yeah, that's the technical term for it. So next, we are going to initialize our position and our pixels per meter. So we're initializing our position the same as we were before, just a little cleaner this time. The syntax isn't as wonky. And pixels per meter, we're going to use the built-in graphics pixels per centimeter on Y. So basically, a centimeter of height on the screen is a meter. Not a perfect calculation, but it works for our game, and that's the best kind of logic to use, is the kind that works for your game. So the next thing we need to do is we need to calculate our adjustment correctly. So adding gravity and scaling as delta every turn is not what we need to do. What we actually need to do is we need to take velocity and we need to add our gravity.x times delta and gravity.y times delta. So we need to add our gravity at delta scale every frame to our velocity, and then we add that velocity adjustment to our position. So every frame our velocity is added to our position. So as gravity keeps applying to our velocity, it'll get further and further, and that'll give us the motion that we would like. So now if we run this, you'll see our game drops, our ball drops right off the screen. So the next thing that I'd like to do is, it's kind of annoying to have to run this every time and just see the ball drop and be like, oh, it's off the screen. So let's reposition the ball back to the original position. If the ball goes below the screen, we will move it back to the top. So what we want to do is, if the position is less than y, or the y position of our ball is less than the height, so basically it has gone below the screen so that you can't see it anymore, then we need to set our velocity to 0 and then reset our position somewhere on the screen. So we're going to go ahead and randomize it while we're at it to somewhere on the x scale between the left and right side of the screen, and back to the top where we had it before. So if we run this now, you'll notice it keeps falling, and now we've got raining soccer ball. So cool. So now what we would like to be able to do is interact with it. So the next thing we'll tackle is actually input polling. Now that we've got the ball moving to gravity, we want to be able to interact with it. So the game will be now to click the ball before it falls off the screen to keep it juggling in the air. So we're going to simulate a kick with our mouse. So we're going to need to create a kick, a variable to hold our kick force. And we'll just set that arbitrarily to 10F, and then we'll see how that feels. The next thing we need to do is we need to see if the user or if the player has clicked on the screen. So there's a bunch of different ways to do this in Libgdx. We're going to use just this basic input polling. So every update we're going to check to see if something was touched and see where it was touched and if that overlaps with our ball. So we're going to I'm going to copy in a block of code here, and then we'll walk through it. And in fact, we'll kind of zoom in a little bit because this is a little bit complicated to read. So we'll just dive in here. So on our update method, we want to check if a button was just pressed. So we don't want to check if it was hold down or if it is down this frame. We want to know if it was just pressed. So this is a utility from Gdx input that says, hey, was it pressed down this frame? So we only get this interaction on this particular frame at the time that they click the button. And we want input.buttons.left. Now, this is the left mouse button. So we're checking, hey, did they just press the left mouse button? Then if they did, we want to find the center. So basically what we need to do once they click with the mouse is we need to make sure that their click is close enough to the ball that they could have clicked it. So we're using a ball, so we can use the distance between the click point and the center of the ball to know if it touches it, since it's a circle. That's the concept we're using here. So we grab the center of the ball, which would be the position, and then we'll add the image width and height, half width and half height. So that will put it so that position will be, instead of being bottom left, that'll move it up to the center of the image. Then we check the mouse position. Now this is more complicated than I wish it was, but this is what we got to do. We put it into a vector. We say input.x, so that'll give us, hey, where the mouse currently is on the x position, and that's all we have to do for x, because x starts at the left at 0 to the right, just like our coordinate system. However, input for the mouse is inverted compared to the position. So the height of the screen minus the input will give us where the mouse actually is in our coordinate system. And you can play around with drawing several different things to really understand this, and I feel like I did not give a good description of what that was. Just know that the coordinate system for drawing is inverted from the input system on the y-axis. So you always have to do that adjustment if you're grabbing the input. So once we have the center of our image and our mouse position, we can say, hey, from the center, the distance to the mouse position, is it less than or equal to half of the image width? If it is, okay, let's add a kick force. So we'll take the center position, subtract the mouse position. That'll give us essentially the angle that that were clicked between the center of the mouse or from the mouse position and the center of the ball. Let's get the normal for it. So that'll just give us the pure direction. And let's scale that vector to our kick force. So we want to kick it at 10. Let's do that. So we'll scale it to the kick force, and then let's just set our velocity to our new force.x, and then always just kick it up the kick force. We cheat a little bit here because we could say force.y, and it would put some of that force more in the left or right direction compared to the y, but just to make the game more fun, it's going to feel better if we just always fake this and give them the full y value. So the next thing we need to do is continue to add our gravity. So we always want to add the gravity after any force that we apply to it. And then we just adjust the position like we were before, and this should give us our game. So let's run the game and see what happens here. So if I click it, you'll notice it'll go this way. So if I click it here, if I click it there, oh, I missed it. Click it, click it. So it works, but it's kind of annoying that it goes off the screen like that. So let's fix that. To make it bounce off the walls, what we need to do is detect if our ball is to the left or right sides and just make it bounce. So just reset, invert the x velocity. So in order to do that, we just need a quick calculation of where the ball is. And we'll do that after we've adjusted the ball position, so that the next frame will pick it up. So if the ball hits the wall, so if our position.x is less than 0, so if we've gone past the left side of the screen, then our bottom left corner will have gone past that left side, then we know we're off that side. If the x is greater than or equal to the width minus the image width, so remember it's the left side of the image, so if we only did graphics width, it wouldn't go until we don't see the ball all the way. So we subtract the image width to make the right side of the ball bounce off. And we will change this to scale on the x inverted. And now our ball will bounce off the wall, and we can kind of play our game in a nice loop. So that's a nice bug. We didn't calculate our random position correctly, so we're kind of going outside of the range, so it got stuck there on the side. That's a bug that I will leave for you all to fix. But now we've got this ball and we can juggle it. Just keep it up. And you've got your first game in Libgdx, written in Kotlin. Alright, I hope you enjoyed the tutorial. I will make sure that links to the source and all of the references that I have used in this tutorial are available below the video, and hope you check out some more LMG content. Thanks.